21. Okay, so the first question in your assignment number 2 reads, the manager of a computer operation of a large company wants to study the company or the computer usage of two different departments, the accounting and research. A random sample of 5 jobs from the accounting past week and 6 from the research, and the processing time in seconds. So you have 2 different companies, 5 in the first one, and departments, 5 in the first one, 6 in the second one. Using 5% level of significance or 95 confidence interval, and conclude, for example, or hypothesis. You can have the option of do it either confidence interval or hypothesis. And to estimate the mean. Okay, first of all, we obviously have 2 sample systems or 2 sample means. But when you have 2 sample means, it could either be independent or dependent. Independent when you have 2 separate groups. Like this one. So you have the accounting, you have the research. They're totally separate, it's an independent. Dependent is when you have one group performing 2 tests. So for example, they tell you you have an item. This item they sell in Sobeys and they sell in Superstore. And they list the items and how much in Sobeys, how much in Superstore. So it's only one sample of items, but there are 2 tests. So here you have 2 separate groups. That's an independent system. So since it is an independent system, I'm going to do a confidence interval. So confidence interval for 2 sample independent. The formula we use is average group 1, average group 2, plus or minus T star SP 1 over first group, 1 over second group. You'll see this in your formula sheet. And you can mention here that group 1, we will consider the accounting. And group 2 would be the research. Sorry. So there are some calculations that we need to do. The first calculation is, what's the average for accounting? Well, you take the calculator. You know, for accounting, you need to add the numbers. So 9 plus 3 plus 8 plus 7 plus 12. They add to 39. And there are 5 numbers, so you divide by 5. So you have 7.8 seconds. Because you know, anytime you do the average, it's a sum over n. So we do the average also for the second company, and that would be the research. But in the A, just reading the A, estimate the mean processing for the accounting. So they don't want you to do it for both at the beginning. Only do it for accounting. So do it as one sample first, and maybe later in the assignment, they'll tell you to do it for the 2. So now we stick to just the accounting. So here we do confidence interval for, forget about this formula. This is for when you compare the two of them. But in A, we're going to do confidence interval for one mean. And if you guys remember what I did for the midterm, confidence interval for one mean, you can either use this, or you could use this. Depending on sigma known, sigma unknown. Sigma would be the standard deviation of all the computers in the accounting. There is no mention in the question of what the standard deviation of all the computers in the accounting. So we're not going to use this. We don't know the standard deviation of population. We don't know the standard deviation of all. So I'm going to use this for the answer. I have the average. I need my standard deviation. To do the standard deviation, I need sum of x squared first. So I go back, I square each number, so 9 squared, 3 squared, 8 squared, 7 squared, 12 squared. This is 3, 4, 7. Then we do the SSX, total variations, and you know it's the sum of x squared minus the sum squared over n, so 3, 4, 7. This is 39, and there are 5 numbers. It gives you 42.8. Then you get the variance, where you take your SSX divide by n minus 1, so 42.8, and you divide it by 4, which is 5 minus 1. This would be 10.7. And finally, the standard deviation would be the square root of the variance. So you square root the 10.7. 3.2711. That's your standard deviation. So we're ready to put everything together. We still need to get the t star. To get the t star, we get it from the t table. We need degrees of freedom, and that would be n minus 1, so 5 minus 1, 4. And we need the confidence interval significance or level, 95 or 5%. So you divide it by 2, it would be 0.5 divide 2, 0.25, because all confidence interval you divide by 2 because it's a two-tail system. So you go to the internet or you use the t-table you have. So to go to the degree freedom 4 and 1 tail or 0.25, I get 2.776. So the number I get so T star is 2.776. You put everything together. Average 7.8. T star 2.776. Standard deviation and the square root of 5. So you bring the first number down, you only do the calculation for this. This would be 4.0609. So your estimation for mu would be you add the two numbers, you minus the two numbers. And of course, you need to explain what this is in English. So in 99 or 95% of confidence intervals based on 5 computers, because they tell you they took 5 jobs. The mean processing time, 5 jobs make it in the accounting department. The mean processing time is between, and you put the two numbers, it's between 3.7391 and 11.8609 seconds. Okay? Now, this is, for the first one is estimating. You always, if you say 95, say at the end with 5% chance of error. So we always prefer, we say at the end 5% chance of error. So this is it for A. Now question B. In question B, is there evidence that the mean processing time in the research department is greater than 6 seconds? Okay, well, to do this, it's easier to do it as a hypothesis. So we start with H0, HA. Or she could be using H0, H1, doesn't matter. Now, in the question, you need to prove that the processing time in research, whether it's more than 6 seconds or not. Now, you always start with H1, and H1 must be consistent with the question. Mean greater than 6, so you go mu greater than 6, and this would be the complete opposite. And the fact that you're 1 or greater than, of course you don't write this in the assignment, but greater than would be your 1 tail. So in H1, you could either prove that you're more, that's 1 tail. You could prove that you're less than something, that's 1 tail. Or you could be proving that you're not equaling something. That's the only case that is 2 tail. In English, true mean processing time in seconds in the research department is not more than 6 seconds, and here is more. So now usually when you do a hypothesis, you have to determine what test you're going to use. And since this is one mean, we're going to use x bar minus mu s over square root of n. This is the one we use for one mean, unless sigma is known. If sigma is known, you replace s by sigma and you put z here. But we don't know sigma, so we'll leave it as it is. Okay, after you do this, it's decision rule. Remember we said it's one tail, and greater than means that it's right tail. And we have t, so we say if t test more, we're going to reject H0. Why we say t-test? Because we're using a t-test. Why more? Because your hypothesis is more. To get this number, we get it from the t-table. Now to get a number from the t-table again, we need degrees of freedom. And in this case, it would be n minus 1. Again, it's for the research, it's a sample of 6. For alpha, I'm going to use 5%. I'm going to just, since there is no alpha given, or which is also level of significance, I'm going to use the 5%. And I'm gonna leave it as it is. I'm not gonna divide it by 2 because it's one tail system. If it's a two tail system, I would divide it by 2. So now I go to the t table. So 5%. 5% one tail, and degree freedom, again, what's the degree freedom? 5, so would be 2.015. So your number you're going to compare to 2.015. Okay, so we did this. Now it's analysis time, also called calculations. So we do the math. To do the math, we need x bar, which is the sum of x over n. So you go to the actual numbers and you just add them all up. 4 plus 13 plus 10 plus 9 plus 9 plus 6, they add to 51. Divide by 6. Gives you 8.5. So that's the average. I also need S, but I know to do it I need to do SSX. This is the formula for the SSX. Sum x squared, you go back, you square each number. And you add them all up, so this is 483. Sum of x is 51. You square and you divide by 6. This will give you 49.5. You find the variance, where you take this, you divide it by n minus 1. So you take the 49.5, you divide it by 6 minus 1, you divide it by 5 basically. And your standard deviation would be the square root of variance. So it would be the square root of 9.9. And this would be 3.0 1464. So now we're ready to put everything together. In the T format. X bar 8.5. Mu, you go back to the hypothesis, everything is based on the number 6. Standard deviation 1464, and it's a sample of 6. This number is 15570 to be exact. Let me just, I think I did something wrong in the calculation of this, so let me do it again. So the difference over 3164 square root of 6. No, actually the number is 1.9463. Okay, so that's your T number. Now we're ready to make a conclusion. Your t-test provided a 19463, which is not more than this. So this condition is not satisfied, so we don't reject H0. Not rejecting H0 means accepting H0. There is no evidence that the processing time is more than 6 seconds. So in English, you have to say what this is in English. We do not have enough evidence to show that the true mean processing time in the research department is more than 6 seconds. There is no evidence that it's more than 6 seconds. Now, in this case, when you don't reject, you have to mention type 2 could be committed. And the risk equals beta. And you don't need to calculate it. And if you end up rejecting, then we say type 1 error could be committed with risk equals alpha, and that's a 5%. It's whatever you used. Okay, so that's for B. The C question, is there evidence of difference between the mean processing time of the accounting and the department and the research? Assume that variances are equal, include the error. Okay. So we're going to do this as a hypothesis testing. So I'm gonna delete this. So now they want you to compare two, so we go back to the fact that it's independent system. So two sample, independent, group one, again, I'll make the accounting, and group two would be the research. Are the two equal, or are they different? So when you do a hypothesis testing for difference, we say mu1 minus mu2 not equal 0, equal 0. This would be that they're the same, and this would be that they're different. We don't have to write this. And the fact that it's not equal, I said it earlier, not equal, that's an indication of the fact that you have a two-tail system. In English, the true mean processing time for accounting and research departments are, this one is the same, we say are not different. This say we're different. So you have, well, you have to spell it out completely, but this one, they're the same, not different. This one, they're different. Now, we need to use the formula for this, and when you have we have a two sample independent. The formula we use, so the test we use for this would be average group 1, average group 2, mu1, mu2, SP 1 over N1, 1 over N2. This is the formula we use. You'll see it in your formula sheet. And then after this, we have decision rule. It's a two-tail system. So if it's a two-tail system, we say this: if T test more or T test less than negative, we reject H0. Why more and less? Because it's a two-tail system. For a two-tail system, we say more or less, reject. That's what we do if it's a two-tail system. Now, to get this number, we need degrees of freedom. Since it's a two-sample independent, degree of freedom would be sample 1 plus sample 2 minus 2. So the first one is 5, the second one is 6, minus 2, you get 9. Again, there is no alpha given, so I'll use alpha of 5%, but I'll divide it by 2. Why we're dividing by 2? It's a two-tail system. The previous question was one-tail system, so I didn't need to. This one, I'll divide it by 2 because it's a two-tail system. You go to your t-table, you go to the degree freedom of 9, and the one-tail alpha 025, it's 2.262. So your t that you're comparing to is 2.262. So now we do the analysis. Now the average of group 1, average of group 2, we did it in the previous question, so we don't have to do it again. The average for this one was 7.8 and the average for this one was 9.5. Now, I need to do SP. And if you go to your formula sheet, there is a formula for SP, and it's basically standard deviation 1 squared n1 minus 1, standard deviation 2 squared n2 minus 1 over n1 plus n2 minus 2. And we did both standard deviations, so I'm just going to plug them all to get my SP. So the first standard deviation when we did it, it was 3.2711. So 3.2711 squared, and it's a sample 5 minus 1. When we did the other one, it was 3.1464. 3.1464. You square this, and it's 6 minus 1 over 5 plus 6 minus 2. So I do this in the calculator now, 2711 squared times 4, 31464 squared times 6 minus 1, which is 5, over, and that will give me an SP of 3.2024. So we did the SP 2024, so now we can put everything together in this formula. Average group 1, 7.8. So this is all under analysis or calculations. So when you do the calculations, you put everything under analysis. Average group 2, 8.5. Mu1 minus mu2, according to this, is 0. So anytime you want to figure out this section of the formula, we call it the top right. You look at your hypothesis, and that will tell you what the number is. Your SP is 3.2024, 1 over the first sample, 1 over the second sample. So we do this. And this will give you negative 0.361. Negative 0.361. That would be the answer for your calculation of the t-test. We're ready to make a conclusion. Conclusion. T-test minus 0.361. Is the minus 0.3 more than this? No. A minus is not more than a negative. Is this number less than this? No. A number less than minus 2 would be a minus 3, a minus 4. So this number, not less. So neither is satisfied. So we, in the decision rule, we say reject these two. So neither satisfied, so once again, do not reject H0. And I mentioned, anytime you don't reject, type 2, error could be committed. With risk equals beta. And you don't need to calculate beta, and if you happen to reject, you would say type 1. So we don't reject H0, meaning we accept it. So that means that there is no evidence that they're different. So in English, we do not have enough evidence to show that the true mean processing time for counting and research departments are different. There is no evidence of HA, there is no evidence that they're different, means they're equal, they're the same. Okay. Now, what assumptions that needed for this? No, the D question first is to estimate the mean difference in processing time based on alpha 5%. Okay. So we do 95% confidence interval to estimate mean processing time. And it would be the same formula we use for the hypothesis, but the confidence interval version, which is average group 1, average group 2, T star, SP 1 over N1, 1 over N2. In terms of calculations, we have everything. T star, we need degrees of freedom. It's N1 plus N2 minus 2. It's 5 plus 6 minus 2. It's time. And alpha over 2 would be 0.5 over 2, 0.25. Now, if you go to your T table, I believe that's the same one we used. Just double check. Yeah, it's the 2.262. So T star 2.262. So we put everything together, average group 1, average group 2, T star 2.262, SP 2024, 1 over first sample, 1 over second sample. So 7.8 minus 8.5. So we do the 2.262, 3.2024, 1 over 5, 1 over 6. This number is 43864. So your mu1 minus mu2 would be between the two numbers. You minus them and you add them. You minus, it will take you down to this number. And when you add them, it'll take you up to this number. And to explain what this is in English, so you say in 95% of confidence intervals based on 5 accounting jobs and 6 research jobs, the true mean difference of processing time between the two departments is between negative 50864 and 3.6864 seconds. And if you're 95 with 5% chance of error. Okay, so the next one is if the assumption of equal variances was not included, what would you change in your calculations? Now, in this case, if the assumptions of equal variances was not provided, so you say, what part is this? E. We would use t-test of x bar standard deviation 1, standard deviation 2 for hypothesis, and T star, we would use this for confidence interval. So the formulas would be different. Instead of SP is when you have equal variances, and if they say you don't have equal variances, then you would use the actual standard deviation, so the formulas will change. Okay. On the basis of the results, I don't know if they want you to redo them though. I think this is enough because the question says the assumptions, what would the change in your calculations? I mean, this would be the change. The formula would be different. Do you have to calculate it again? I don't know. I don't think so. But I don't know why it's worth 3 points. Yeah, the other ones are 9.5. So I think you just mentioned the formula is. On the basis, compose a short paragraph of your finding for the director of the information system concerning the two departments. So you tell them there is no significant difference in processing or mean processing time between the two departments. But try and make this look like a paragraph. So I would tell the director that there is no significant difference in the mean processing time between the two departments. So make it a little bit more professional, I say. So this is the first question. It's a long assignment. So I'm gonna stop. This will be part one of your videos. I'm gonna stop and later I'll start part two.